Hey guys, so today we're going to start solving rational equations. I just want to let you know I am so proud of the work that I'm seeing from you guys. You did a great job simplifying rational expressions. Today is going to build off of that. So if you did not do last week's stuff, please do it. If you have questions that I can help you with, email me, come to office hours. If you have suggestions on how I can support you better during this time, I'm also open to that. Guys, I'm not sensitive. So tell me what's good, tell me what's bad. I love to hearing from you. So please, please, please email me with questions, concerns, comments, whatever. All right, so your steps. If you need to pause this, go ahead and pause this, but we do not like fractions, or as a class, we've learned that we don't really like fractions. So we're going to eliminate the fractions by multiplying by our LCD. Then we're going to simplify and solve. We're going to check our solution, and we're going to make sure to exclude any solution that would produce a denominator of 0, because remember in math, 2 golden rules are you cannot, why is it making me add it to, we can't divide by 0. You guys have seen me write this on our board a zillion times, and we cannot even root a negative number. So these things are impossible all the time in math. Okay, so slide 2. Number 1, we have this equation. So our first step, we are going to eliminate the fractions. So this fraction is saying divide by 3. So in order to undo dividing by 3, we can multiply by 3, right? Multiplying by 3 gets rid of dividing by 3. Those are inverses. If I want to get rid of dividing by 6, I can multiply 6, but the trick is to see that 6 factored is really 3 times 2, so that 3 is common, just like when we were making our least common denominators with adding and subtracting. So I don't want to use the 3 twice. I'm just going to multiply by 3 and 2. So now what's tricky here is I need to take each part. So make sure you grab that negative, kind of like we did when we were adding and subtracting, and I can write the 3 and the 2. I'm just going to write it in factored form. This one's going to be a 1. So if my LCD is 3 and 2, I'm going to take each part and multiply it by 3 and 2. So I'm going to squeeze it in, and I just put it over 1 so that I remind myself what was really on top. So now we're going to use last week's first lesson, multiplying and dividing. So when you multiply and divide, anything on the top can cross out anything on the bottom. So these 3's just eliminate to be 1, and then I'm left with 2 times 2y is 4y. Over here, these 3's go away to be 1, the 2's go away, so I just have negative y plus 3. And then over here, there were no denominators, so I'm just going to do 2 times 3, which is 6, times another 2 is 12. Once you get here, this is a really easy equation, so you guys should be excited to see an equation like this. So all I have to do is remove my parentheses, so I'm going to distribute that negative 1, and that gives me negative y minus 3. Combine these like terms, so 3y minus 3 equals 12. Add the 3, so 3y is 15. Divide by 3, and y is 5. So check for your restrictions. This one's kind of easier because there's no variables down here. There's no variable value. Like if I put 5 in for y, that's not going to do anything to my denominator because there's no variable down there. So there's no restrictions for this one. So my answer is just 5. All right, if you need to pause to make sure you can write that down, or you can rewind, right? All right, let's look at number 2. So number 2, some of you learned in middle school or in Math 1 just to cross multiply this, which still is absolutely true. But the reason why cross multiplying works actually is because my LCD for this one would be x minus 1. This fraction needs x minus 1. And 12, this fraction needs 12. So if I multiply each side by my LCD, so I'm just going to give myself some space. So I'm going to multiply by x minus 1 times 12 and x minus 1 times 12. Now I'm going to cross out any tops and bottoms I see. So x minus 1, 12 times 4 is 48. That would be the same thing as if I just cross multiplied Some of your teachers said the butterfly method. Most of us advanced math teachers don't like that. But over here, we'd get x plus 1, x minus 1. So you should be thinking difference of squares there. So now I'm just going to go ahead and FOIL that. So I'd have x squared minus x plus x minus 1 equals 48. So combine your like terms over here, and these go away. Since I have a square and I do not have a linear term, I can use square root property for this. So I'm actually just going to get the square by itself and then take the square root. So a lot of you forget that when we square root, we should get a plus and a minus. So my potential answers for this are x equals 7 and x equals negative 7. Now let's go back and just look at restrictions. So it might be helpful if we start using those restrictions at the beginning. If I have a denominator of x minus 1, I need to make sure that that's never equal to 0. So if I solve this, this tells me that x can definitely not equal 1, because if I plug 1 back in, 1 minus 1 is 0, and anything 0 is undefined. So I need to make sure if I got 1 for an answer that I don't include 1 in my solution. Since my answers were 7 and negative 7, I don't have to worry about that for this one, but it will show up. All right, here's number 3. So number 3, we're going to start by doing our LCD. This one's LCD is x minus 2. My denominator is x minus 2. This one has the same one, so I just need it once. And then this one is 1. So I am going to give myself some room here to multiply by that LCD. While I'm doing that, let's think of what restrictions would make this denominator equal to 0. In other words, what minus 2 would make that equal 0? So this is going to be, oops, sorry about that. X cannot equal 2, because if I put a positive 2 in here, that's going to make my whole function undefined. So we want to make sure that we like set an alarm in our head so that we know if we get 2 for a solution, it can't be 2. All right, multiply each by the LCD. So I'm going to put x minus 2 over 1 next to this one, x minus 2 over 1 minus over 1 times that one, times each part. So these cross out, and I'm left with x. These cross out, and I'm left with plus 4. There's nothing over here, so I need to take 10 times all of that. So that would look like 10 parentheses x minus 2. And now I'm just going to go ahead and solve what's there. So x plus 4 equals 10x minus 20. Once those fractions are gone, our level of anxiety should decrease. So now I just have a basic linear equation. So I'm just going to isolate to get x by itself. So I move the x's to one side, and now I'm going to add the 20. So I'd get, let me go over here, 24 equals 9x. Divide by the 9. So x equals 24 ninths. And 3 does go into 24 and 9. So 3 goes into 24. How many times, guys? 8 times. So this answer should be 8/3. I hope that makes sense. All right, let's move to the next one. So what I noticed is I have a section right here. This is actually not factored. So before I even start, I might as well just make some room, because I know I have lots of fractions in this one to get rid of. And I'm going to factor this other one. So multiply to be 12, add to be negative 7, negative 3, and negative 4, which is kind of nice because I see them over there. So when I find my LCD, the first part needs an x minus 3. The second part needs an x minus 4, which is not common. And this right side of my fraction needs x minus 3, which is common, and x minus 4. So what are my restrictions here? What can x not be? If I can't divide by 0, then x can't be 3, and x can't be 4. So I want to make sure I watch out. If I get positive 3 or positive 4, those would definitely make this whole thing undefined. So next step is going to be to squeeze in my LCD, oops, and not slide, next to each part At this point, some of you might see that you really are just going to multiply by what's not on the denominator, and that's fine if you want to go ahead and kind of give yourself a shortcut there. So like this one, the x minus 3s are common, so I'm just going to have the 3, x minus 4 here. X minus 4s are going to cross out here, so I'm going to have 4 x minus 3. I always tend to put the monomial before any binomial. And over here, this is really nice because both of those factors cross out and I just have 25. Whew, I'm excited to see this one. This is easy. All I have to do is distribute the 3, distribute the 4. All right, combine my like terms here. 3x and 4x is 7x. Negative 12 and negative 12 is negative 24. I'm going to add 24. So this is going to give me 7x equals 49. Divide by 7, and x is 7. Check to make sure that x is not 3 and x cannot be 4. Remember, these are restrictions, so they can't be that. You can now go back in if you want, and we should have technically done this to all of them, and put 7 in to make sure that this makes a true statement. So you can check with your calculator, or you could check by hand. So 3 over 7 minus 4 would be 3/4. 4 over 7 minus 4 would be 4/3. 25 over 49 minus 49 plus 12 would just be saying 25 over 12. So now you can get these common denominator and add them, or you can simply just put left side in your calculator, right side in your calculator, and make sure that they're the same. Okay, last example. So we see again, we're going to have to factor. So I'm going to leave myself some room to get rid of those fractions to ease. Y squared plus 16 is a sum of squares. You cannot factor a sum of squares. You can factor a sum of cubes, but not a sum of squares. Y squared minus 16 is a difference of squares. So A would be Y, B would be 4, right? Because this is A squared and B squared. And then A plus B, A minus B would just look like Y plus 4, Y minus 4. All right. So LCD and restrictions. This one needs y plus 4. This piece needs y minus 4, which is not common, so I'm going to include it. Both of these are common, so I don't need them again. I need to make sure that my denominator never equals 0, so my restrictions here, y plus 4 can't equal 0, so y cannot equal negative 4. Y minus 4 cannot equal 0, so y cannot equal positive 4. So I want to watch out for those. All right, and then I'm going to take each piece and multiply it by my LCD. Y plus 4, y minus 4. Squeeze it in. We can go through these on office hours. All right, this would be y minus 4. Over here, we'd have 4, y plus 4. And over here, again, love when this happens. I'm just left with my numerator. All right, definitely need some more room here. So no fractions, so that's great. I'm going to distribute the y. So y times y is y squared. Y times negative 4 is negative 4y. Now distribute that 4. 4 times y is 4y. 4 times 4 is 16. And then I have y squared plus 16 over here. So combine your like terms, leaves me with y squared plus 16 equals y squared plus 16. So I have exactly the same thing on the left and right. So some of you might be kind of robotic and be like, oh, well, I need to get my variables to one side. So if I eliminate those, I'm left with 16 equals 16. So this you might not have seen since Math 1, but when you have a number equal to that same number, this is actually all real numbers. Let's imagine that this 16 was actually a 15 and I had like 15 equals 16. This would be no solution. That's not the case for this one. That was a imagine. But if we got a number that didn't equal the same number, that would be no solution. So typically in Math 1, it would be all real numbers. But in Math 3, we talk about these things that are restrictions. So when I write my solution set, I can say all real numbers except -4 and 4, because those would make it undefined, since it would make me divide by a 0, and I'm not allowed to do that. Or you can write your solution set as negative infinity to -4 union 4, -4 to +4 union 4 to infinity. So pretty much, because I'm using parentheses in my interval notation, it's saying skip this number, skip that number again, skip that number, skip that number. So it's all of the numbers from negative infinity to -4, jump over -4, go -4 to 4, jump over +4 and go 4 to infinity. Next week, we're going to look at the graphs of these. So this should all then connect in your brain. All right, here are some exit questions that I'd love to do during office